Welcome students to the lecture number 9 of computer system architecture. The main objective of this lecture is to understand what is flip-flop and what are the various types of flip-flops. So let's start our discussion with what is a flip-flop. Students, flip-flop is an electronic circuit which is used to store one bit of the binary information. It can store a 0 or it can store a 1. Flip-flop can receive 2 or 3 inputs which depend upon its type, and a flip-flop can give 2 outputs in the result, and these outputs are complement of each other. The various types of flip-flop that you will study in this lecture are SR flip-flop, D flip-flop, JK flip-flop, and T flip-flop. Students, before starting our discussion on the various types of flip-flops, let's first understand what is a clock pulse. Students, one of the input of all the flip-flops is clock pulse. Clock pulse is a signal which is generated by clock pulse generator. Clock pulse has only two states, low and high. Low is represented by 0 and 1 is represented by 1. The diagram of the clock pulse is visible on your screen. The role of clock pulse is to maintain synchronization in the operations performed by the various circuits of the computer. A circuits do not perform any task until it receives signal from the clock pulse. It means that a flip-flop will remain in idle state until it receives signal from the clock pulse. Okay. Students, now let's start our discussion on the various types of flip-flops. Firstly, we will discuss the SR flip-flop. Students, the SR flip-flop is also known as set reset flip-flop. It receives three inputs. First one is S, second one is clock, and third one is R. And it gives two output, and which are the complement of each other. So the outputs are represented as Q and Q dash, or the Q complement. Students, let's now understand the working of SR flip-flop. Firstly, we need to understand that when the clock input is low, then the flip-flop will remain in its present state, whatever the values of the inputs S and R. Okay. Students, the flip-flop will start its functioning only when the inputs of the clock input is high. Let's now discuss the possibilities of inputs when the clock input is high. Firstly, suppose the value of S is 1 and the value of R is 0. In this case, the output Q will be 1, and this operation is known as the set operation. The second case is when the value of the input S is 0 and the value of input R is 1. In this case, the value of the output Q will be 0, and this operation is known as the reset operation. The third case is when the value of S is 0, the value of R is 0. In this case, the value of output will remain unchanged. It will remain as its previous state. Okay. Now the fourth possibility is when the value of S is 1 and the value of R is also 1. In this case, the output is indeterminate. Students, because the SR flip-flop give an indeterminate state, so this flip-flop is very rarely used in practice. We use the improvised form of the SR flip-flops, which are JK flip-flop, D flip-flop, and T flip-flop. Okay. Students, the characteristics table or the truth table of SR flip-flop is visible on your screen. You can see that when the value of S and the value of R is 0, then the output will remain unchanged. If it is 0, then it will remain 0, and if it is 1, it will remain 1. Okay. Now the second case is when the value of S is 0 and the value of R is 1. In this case, the value of output will be 0, and this operation is known as the reset operation. Now the third case is when the value of S is 1 and the value of R is 0. In this case, the output will be 1, and this operation is known as set operation. Students, the fourth case is when the value of S is 1 and the value of R is 1. In this case, the output will be indeterminate. It can be 0 or it can be 1, so it is represented by indeterminate state. Okay. Students, let's now discuss second type of flip-flop, D flip-flop. D flip-flop is also known as the data flip-flop. D flip-flop receive two inputs. One is represented by D and the other is represented by the clock. Okay. and it gives two outputs. One is Q and the other one is the complement of Q, which is represented as Q dash. Students, the D flip-flop is also created from the SR flip-flop. To create a D flip-flop, we combine the uh, inputs S and R and we insert an inverter between them. After that, we assign the single input to the inputs S and R, and this single input is known as D input. Okay, students, let's now understand the working of D flip-flop. When the clock input is low, then the flip-flop will remain in its same state. It will retain its state, whatever the value of the D input is. Okay. Now, when the clock input is high and the value of D input is 1, then the value of the output Q will be set to 1, and this operation will be known as the set operation. Okay. Now the second case is when the clock input is high and the value of the input D is 0. In this case, the value of the output will be 0, and this operation is known as the reset operation. Okay. Students, the characteristics table or the truth table of D flip-flop is visible on your screen. You can see that when the value of D is 0, then the output Q will be 0 and it will be the reset operation. Okay, and the value of D is 1, then the output will be 1, and this is known as the set operation. Okay, the characteristic equation of a D flip-flop is Qt plus 1 is equal to D, because the value of Q is always equal to the value of the input D. Okay, students, let's now understand JK flip-flop. JK flip-flop is an improved SR flip-flop. In this case, we have removed the problem of indeterminate state of SR flip-flop. The JK flip-flop receive three inputs. One is represented by J, one is represented by K, and the third input is clock input. Okay, and it gives two outputs, Q and Q dash. Students, let's now understand the working of JK flip-flop. Similar to the SR flip-flop and D flip-flop, when the clock input is low, then the flip-flop will remain in its previous state, whatever the values of the inputs J and K. Okay, so when the input is high and when the value of J is 1 and the value of K is 0, in this case the output Q will be set to 1, and this operation is known as set operation. Okay, now the second case is when the clock input is high and the value of J input is 0 and the value of K input is 1. In this case, the value of output Q will be set to 0, and this operation is known as the reset operation. Okay. Now the third case is when the clock input is high and the value of J input is 0 and the value of K input is 0. In this case, the output Q will remain unchanged. It will retain its previous value, whether it is 0 or whether it is 1. Okay. Now the fourth case is when the clock input is high and the value of J input is 1 and the value of K input is 1. Students, in this case, the output Q will be the complement of its present state. If it was 1 at present, then it will be 0 in the next step. And if it was 0 at the present, then it will be 1 in the next step. Okay. Students, the characteristics table or the truth table of JK flip-flop is visible on your screen. You can see all the possible combinations here. So when the value of J is 0 and the value of K is 0, then it will retain its previous state. It is represented by Qt. And when the value of J is 0 and the value of K is 1, then the output will be 0 and it will be represent the reset operation. Okay, and the value when the value of J is 1 and the value of K is 0, in that case the output Q will be 1 and it will represent the set operation. And when the value of J will be 1 and the value of K will be 1, in this case the output will be the complement of its present state. Okay, students, let's now discuss T flip-flop. T flip-flop is also known as the toggle flip-flop. The T flip-flop receive two inputs. One is represented as T and the other one is the clock input. Okay, and it gives two outputs, Q and the complement of Q, which is represented by Q bar. Students, to create T flip-flop, we need a JK flip-flop. In JK flip-flop, we combine the inputs J and K, and we assign the single input T to it. Okay, students, let's now understand the working of T flip-flop. When the clock input is low, the flip-flop will retain its state, whatever the value of input is. Okay. Now the case number 2 is when the clock input is high and the value of the input T is 0. In this case, the output Q will be the same as that of its present state. It means it will retain its state. Okay. Now this operation is similar to the operation when the value of J was 0 and the value of K was 0, and in that case the output was QT. Okay, students. Now students, the next case is when the clock input is high and the value of input T is 1. In this case, the output Q will be the complement of its present state, and now this operation is also similar to the operation when the value of J was 1 and the value of K was 1 and the output was Q dash T, or the Q complement. Students, let's now discuss the characteristics table, or the truth table of T flip-flop. The truth table of T flip-flop is visible on your screen. It is clear that when the value of input T is 0, in this case the output will remain as such. It will not change its present state. And when the input T is 1, in that case the output will be the complement of its present state. Okay. Now the characteristics equation of T flip-flop is Qt exclusive or T. Students, these are some concluding point of this lecture. Students, flip-flop is a circuit which store one bit of binary information. Okay. Now we have four type of flip-flops. First one is SR, second one is JK, third one is D, and fourth one is T flip-flop. The SR flip-flop is the basic flip-flop, but this flip-flop is seldom used because this gives an undetermined state when the value of S is 1 and the value of R is 1. Okay. JK flip-flop is an improved form of SR flip-flop, and in this flip-flop we remove the undetermined state of the SR flip-flop when the value of S was 1 and the value of R was 1. Okay. The D flip-flop is made from the SR flip-flop, and in this case the output will be similar to the cases when the value of S is 0 and the value of R is 1, and when the in the second case is when the value of S is 1 and the value of R is 0. It means it perform only two operations, set and reset operations. Okay. Now the fourth flip-flop is T flip-flop, and it is made from the JK flip-flop. Its output is similar to the cases when the value of J is 0 and the value of K is 0, and when the value of J is 1 and the value of K. It means it perform two operations. Either it retain the value of the uh, state of the flip-flop, or it make a complement of its present state. Okay. Students, this is the end of lecture number 9 of computer system architecture. I hope you have understood today's objectives. Thank you for attending this lecture. See you in the next lecture.